Hi, my name is Destiny Lewis, and today I'll be presenting my Project 3 for my Design and Manufacturing course at Georgia Tech. This is submitted to Dr. Hassan Rashidi for the fall 2024 semester. Disclaimer, this presentation was created solely for education purposes as a part of a course assignment. This is just for education purposes. So, Project 3, we were tasked with presenting 5 topics we enjoyed the most, ensuring that we include a summary of the topic, why we liked it or why it was important, its capabilities and limitations, and any of the resources that we used throughout the presentation. In our design and manufacturing course, we've learned various techniques, topics concerning tools, models, processes, and strategies that are used in design and manufacturing. So my first topic is designing for X. Designing for X refers to designing with goals, constraints, or certain features in mind. It helps align the design process with the needs of the end users, which overall leads to a more efficient development process. Designing for X could be designing for manufacture, assembly, disassembly, service, ease of use, sustainability, etc. I'm focusing in particular on designing for assembly, and I'll get into why soon. Designing for assembly ensures that each component of a product is designed so that it meets requirements and specifications. It can be assembled economically, intuitively, easily, and fast. Why do I like designing for X? As a mechanical engineer or project designer in general, through this entire design process, it's really important to keep certain factors in mind. For example, I'm currently pursuing a minor in industrial design and I'm taking a course called parametric modeling, where the whole course revolves around building intelligence and SOAR models. I've encountered several issues throughout various assignments when it came to modeling because I wasn't fully considering various designing for X principles. As a result, when I changed certain parts of my model, other parts wouldn't update because I wasn't building it parametrically. In our most recent assignment, we had to model and print a phone case, and I kind of overlooked the tolerance considerations when it came to the screws that will hold both sides of the phone cases together, and also the tolerance around my phone. So it fit a little bit too snug, and I had to reprint it, and I'm currently going through the process of redoing this assignment. But nonetheless, if I was considering the designing for assembly, I would have been more careful when it came to, adding tolerance, and of course, figuring out how I would fasten the back and front. This experience has shown me the value of designing for X for both my current coursework and my future career. Some capabilities: designing for X allows for precise focus on specific goals like cost, feasibility, or sustainability. It streamlines the manufacturing process and it can help reduce costs. It could also create products that are more user-centric or environmentally conscious. Some limits: optimizing for one of the objectives can kind of compromise the others. There could be higher initial costs because you're focusing, on a certain aspect, and that could require more tedious or more material per se. And also balancing multiple goals can overall complicate the design process, but this is my topic 1. Topic 2 is forging, and I included this cute little video of what forging is. But basically, forging is a process where metal is heated and shaped by applying strong pressure. This also makes it more tough or more durable, and instead of melting per se, the metal is softened, then hammered or pressed into shape. The types of forging: there's open die forging, closed die forging, drop forging, and press forging, and I have descriptions of all of those there as well. Why do I like forging? Overall, I chose this because I thought it looked pretty cool. And this is why I kind of focus more on why it's an important process. It's more than just something that looks pretty cool. So forging is important because it creates parts with superior resistance to stress and fatigue, which is so important. Also, it creates more durable projects. Forged parts are usually tougher and more wear resistant. And of course, efficiency. This reduces waste and helps lower cost. So the capabilities when it comes to forging, of course, like I just mentioned, parts are produced with superior strength due to aligned grain structure. Parts are also more resistant to wear, fatigue, stress, and it can be used for a wide range of metals and part shapes. Some limits: it could be a tad bit more expensive to set up such machinery, especially for complex or large parts. Forging is typically limited to smaller parts and medium-sized parts, so it might not be the best for something that's a little bit more large and requires, more. And also, complex geometries may be difficult to achieve without additional processing. So, circles and squares might be okay, but maybe stars or octagons might be a little bit harder to do with a forging process. But overall, this is my topic 2. Topic 3, I chose digital twins. Now, we kind of briefly touched on that in class, but it was mentioned in one of Dr. Hassan Rashidi's articles that I put in my resources as well. But the reason why I chose this, I'm going to get into it soon, but it was kind of really cool. But basically, virtual twins are advanced models that combine real-world data with digital designs to simulate the behavior and performance of objects, systems, or entire processes. The models are constantly updated with real-time data through sensors and various technologies, which allows businesses to optimize their operations, predict failures, and improve overall performance. So why do I like digital twins? Well, recently I attended a conference featuring Georgia Tech alumni where two speakers were from Siemens USA, and they shared insight about how they're using their mechanical engineering degrees, but they touched on how they use digital twins at their company. And like when they were talking about it, I knew what digital twins were because of this course. And my friend next to me was asking like, what is like, what are digital twins? And I was like, oh, I got you. I know what digital twins are. All thanks to this course. Some capabilities about digital twins: they allow for the continuous monitoring of systems. They allow businesses to predict potential failures and optimize operations. And they also eliminate the need for physical prototypes, which streamline the product development as a whole. Some limits: the effectiveness is constrained to the quality and quantity of the data from the sensors. So if something's impacting the sensors, it could skew the data. Setting up virtual twins requires a lot of investment, so it may not be good for small businesses, and also integrating it into existing systems can be challenging overall. Fourth topic, extrusions. So extrusion is a manufacturing process where a material is forced through a die to create continuous shape with a fixed cross-section. The material is heated until it becomes soft or molten, and then it is pushed through a mold to form products such as pipes, profiles, or sheets. So why do I like it? Well, I was first introduced to extrusions in ME 1670 through SolidWorks, and as a naive freshman at the time, I didn't consider the real world applications, and I thought extrusion was simply just what the feature or the function was called. And it's fascinating to see how it's an actual thing in real life scenarios. And ultimately, much like in SolidWorks, I appreciate how extrusions for the simplicity in creating specific shape profiles. So some capabilities of extrusions: they allow for a variety of complex profiles. They allow for mass production of uniform parts with minimal waste. This should say limits, but extrusions are less suitable for parts with intricate or high detailed geometries. Not all materials are suitable for extrusions, and the cost for necessary dies and molds could be high. So my last topic, I know I'm cutting time, is lean manufacturing. So lean manufacturing is a production that focuses on maximizing value by minimizing waste and improving efficiency. And it is focused around 5 key principles: value stream, flow, pull, and perfection. So value is defined as what's valuable to the customer. We have to focus on those that like what's valuable to the customer. Value stream identifies all the steps in the process and eliminate those that don't add value. Flow ensures that everything is flowing smoothly without interruptions. Pull produces goods based on customer demand rather than like, oh, customers might want Halloween candy, for example, because it's getting closer to Halloween. It focuses on what consumers are like, what they're demanding at the moment per se. And the perfection, continuously improving the process to eliminate waste and enhance efficiency. Like, what if you know that Halloween's coming up and you make too much Halloween candy per se? Why do I like it? So I like it because I believe it's really efficient. It can make a company much more efficient. And then I get into why it's more important, because like I was saying before with forging, it's better to focus on why this is an important thing overall. So lean manufacturing is important because it helps organizations improve efficiency, reduce rate, and cut costs. Some limits to lean manufacturing is that it can be difficult to implement in an organization with deeply ingrained traditions. Like, if a company's been doing something for so many years, why would they come and implement this procedure per se? It may struggle in an environment where demand is highly unpredictable. So you can't it just changes every day, so demand one day might not be the same the next day, and that's kind of difficult to work around. And some capabilities: lean manufacturing can significantly reduce waste, which is always good in a company, and it overall enhances product quality through continuous improvement by streamlining processes to eliminate defects. So here are my resources. Like I mentioned, I did use an article that was created by Dr. Hassan Rashidi, shout out. I also heavily use the textbook, so that's also listed, as well as other websites that I did turn to find information. Thank you so much for listening. This is the end.